Have you ever looked up at the night sky and wondered why it's so dark? Even though there are so many stars up there. You might think that if there are so many stars, the sky should be full of light, right? Well, let's dive into this mystery. Space looks black because, even though there are countless stars scattered across the universe, the space between those stars is empty or nearly empty. The stars we see are shining bright, but the light from them doesn't travel through the vast emptiness of space in the way we might expect. In space, light from distant stars can travel across huge distances, but it doesn't really fill the sky the way we might think. Instead, it just gets spread out and becomes dimmer the farther away it goes. You can imagine space like a giant dark room with a few light bulbs in it. If you stand right next to one of the light bulbs, you can see its bright light. But if you step far enough away, the light gets so weak that it's hard to notice. Even though there are many stars in space, they're spread out so far that their light doesn't combine to light up the whole sky. Another reason for the blackness of space is that space is mostly empty. There are very few particles or gas out there to scatter light, like the air on Earth does. On Earth, the atmosphere scatters sunlight, which is why the sky looks blue during the day. But in space, there's no atmosphere to scatter light, so it doesn't get spread out, and the sky stays dark. In the end, space looks black because of the enormous distances between stars and the emptiness in between them. It's like looking into a huge, dark ocean with tiny points of light scattered across it. The stars shine, but they don't light up the entire space around them because there's just so much empty room. Imagine you're sitting on a hill on a clear night, looking up at the sky full of stars, and you wonder, what's really out there? This has been a big question for people for thousands of years. So what exactly is the universe? The universe is everything we know, the Earth we live on, the stars we see, and so much more. It's made of all the planets, stars, galaxies, and even empty space itself. It's so enormous that even the smartest scientists can't fully understand it all. One amazing thing about the universe is that it's constantly expanding, kind of like a balloon getting bigger and bigger. As it expands, the galaxies, stars, and everything in space move further apart. But did the universe have a beginning? Yes. Scientists believe it all started with something called the Big Bang, about 13.8 billion years ago. Picture everything squeezed into one tiny, super hot point, and then boom, it explodes, and the universe begins to grow. That's what the Big Bang Theory tells us. Everything started from that one powerful explosion, which spread energy and matter across space, and created the universe as we know it. So does the universe have an end? That's a mystery. No one knows for sure, but scientists have some ideas. One idea is that the universe will keep expanding forever, getting colder and emptier over time. Another theory suggests that one day the universe might start to shrink back in, like a balloon deflating, and could end in a big crunch. There's also a strange theory called the Big Rip, which says the universe might keep expanding until everything eventually tears apart, even down to the smallest particles. In the end, the universe is like a giant story with endless chapters. We've only read a tiny part, and there's so much left to explore and understand. The mystery of where it all began and where it's going keeps scientists and dreamers like us looking up, wondering what's really out there. Imagine you're floating in space, surrounded by stars and planets, but you're not standing on anything. You don't feel heavy at all, and you can float and move around as if you were weightless. But how is that possible? When we say space is weightless, what we really mean is that there is zero gravity, or at least very little gravity, pulling on you. Gravity is the invisible force that pulls objects toward each other. On Earth, gravity pulls us toward the ground, which is why we stay on the ground and don't float away. But in space, especially far away from big objects like Earth, gravity is much weaker. In space, astronauts often experience what we call microgravity or zero gravity. This doesn't mean there's no gravity at all. There's still a tiny bit of gravity everywhere, but it's so weak that objects and people don't feel it. Instead of being pulled down to the ground like we are on Earth, astronauts and objects in space float freely, which is why we see astronauts floating in their spacecraft. So, how does this happen? When an astronaut is in orbit around Earth, they're actually falling toward the Earth because of gravity, but Earth's gravity is pulling them sideways at such a high speed that they keep missing the Earth. It's like trying to throw a ball around the Earth. If you throw it fast enough, it won't fall to the ground. It will just keep going around the planet. This creates the feeling of floating, because everything in the spacecraft, including the astronaut, is falling at the same rate. Since there's nothing to push back against them, they feel weightless. In space, you're not truly floating, because there's no gravity at all. It's just that everything around you is falling at the same rate, so it feels like you're weightless. It's like being in an elevator that's falling. Everything inside the elevator floats, even though gravity is still pulling things down. This is what makes space feel so different from life on Earth. If you've ever looked up at the stars and wondered, could there be life out there, somewhere? You're not alone. Scientists have been asking this very question for a long time. The universe is huge, much bigger than we can even imagine. It's filled with billions of stars and planets, and some of those planets are in a special Goldilocks zone, not too hot, not too cold, just right for liquid water, which is a key ingredient for life as we know it. So, is there life somewhere out there? The short answer is, we don't know yet. But the longer answer is that many scientists believe it's possible, maybe even likely. With so many planets out there, it seems like it would be very rare for Earth to be the only place with life. In fact, scientists have discovered thousands of exoplanets, planets outside our solar system, some of which might have the right conditions for life. One of the main places scientists are looking for signs of life is on planets and moons in our own solar system. Mars, for example, has been a big focus. It has signs that liquid water once flowed on its surface, and where there's water, there's a chance for life. Similarly, moons like Europa, one of Jupiter's moons, and Enceladus, a moon of Saturn, are covered with ice. But scientists think there might be liquid water underneath the ice. If there's water, there could be life, maybe tiny microbes or even something more complex. But here's where it gets even more interesting. Life elsewhere might not look like anything we've seen on Earth. On Earth, all life is based on carbon and uses water as its main liquid. But in space, scientists think there might be different forms of life that use different chemistry. Imagine life that doesn't need water, maybe something that uses liquid methane, like the lakes on Saturn's moon Titan. Or perhaps life forms that don't need sunlight, like the creatures found deep in Earth's oceans around volcanic vents. These organisms don't rely on sunlight for energy. Instead, they use chemicals from the Earth's crust, a process known as chemosynthesis. If life exists on other planets or moons, it might be very different from what we expect. It might not need oxygen to breathe, and it might not even use carbon to build its body. It could be based on completely different building blocks we can't even imagine. The possibilities are endless. Some scientists even wonder about the possibility of life that is entirely alien to us. Life that doesn't use any of the things we consider essential. For example, could there be life forms made of silicon instead of carbon? Silicon shares many properties with carbon, so it might be able to form complex molecules in ways similar to carbon. Or could there be life forms that don't need to eat or breathe at all, but instead use something entirely different to survive? Even more mind-blowing, there could be life that we just can't recognize because it's so different from what we know. For example, could there be beings that exist in ways we can't even see, like life forms made of energy or plasma rather than solid matter? But why haven't we found any signs of life yet? It's called the Fermi paradox. It's the idea that with so many planets out there, we should have found some sign of life by now. Maybe it's because the life we're looking for is very far away. Or maybe it's because we're just not looking in the right way yet. After all, the technology we have now is still very limited compared to what we might have in the future. In the end, whether we find life or not, the search itself is one of the most exciting adventures humanity has ever embarked on. The universe is so vast, and we've only just begun to scratch the surface. Whether or not we find life, the possibility that we could, is enough to keep us dreaming and exploring. The more we learn, the more we realize how much we have yet to discover. The universe is full of mysteries, and one of the greatest might just be whether or not we are truly alone. Imagine this. You're floating in space, looking at a star-studded sky, and suddenly you spot something strange, a region of space where not even light can escape. This invisible force is called a black hole, and it's one of the most mysterious and powerful objects in the universe. But what exactly is a black hole, and how can something so strange exist? To answer that, we first need to understand how stars work. Stars, like our sun, are massive balls of gas that burn fuel and give off energy through a process called nuclear fusion. This process creates heat and pressure that pushes outward, balancing the force of gravity, which tries to pull everything inward. But when a star runs out of fuel, things start to change. In some cases, if the star is big enough, gravity wins. The core of the star collapses in on itself, causing the star to shrink into an incredibly tiny and dense point called a singularity. This is where a black hole forms. It's like taking the mass of a huge star and squeezing it into a space no bigger than a marble. The gravity in this tiny space becomes so strong that it pulls everything, even light, into it. This is why we can't see black holes. They don't let any light escape, so they're completely invisible. Around The singularity is a boundary called the event horizon. This is the point of no return. Once something crosses this boundary, it can never escape, not even light. Imagine trying to escape a steep, slippery hill where every step pulls you downward. Once you're past the event horizon, there's no coming back. So how can something so powerful exist in space? The answer lies in the extreme forces involved. A black hole has an incredibly strong gravitational pull because its mass is packed into such a tiny space. The gravity around a black hole is so intense that it warps the fabric of space and time itself. This is a phenomenon known as space-time curvature. Think of it like a trampoline. If you place a heavy ball in the middle, it bends the fabric of the trampoline, causing anything placed nearby to roll toward it. Black holes bend space-time so much that everything near them is pulled in, unable to escape. Interestingly, black holes can come in different sizes. The ones formed from massive stars are called stellar mass black holes, and they're typically 10 to 100 times the mass of our Sun. There are also supermassive black holes, which are found at the centers of most galaxies, including our own Milky Way. These supermassive black holes can be millions or even billions of times more massive than the Sun. Despite their size, they don't consume everything in sight. They only pull in matter if it gets too close. Another fascinating thing about black holes is that they can grow by merging with other black holes, or by pulling in gas and dust from nearby stars. This process releases enormous amounts of energy, and scientists can observe the effects of this energy through powerful telescopes. In fact, black holes might not be completely invisible after all. When matter falls into them, it heats up and emits a bright light, known as accretion. But here's the biggest mystery. What happens inside a black hole? No one really knows. Once something crosses the event horizon, it's lost to us forever, and we can't see what happens beyond that point. Some scientists think that all the information about the matter that falls into a black hole is lost forever, while others think that black holes could be portals to other parts of the universe, or maybe even to other dimensions. In the end, black holes are some of the most mysterious and fascinating objects in space. They challenge everything we know about gravity, space, and time, and scientists are still trying to unlock their secrets. The more we learn, the more we realize just how strange and wonderful the universe truly is. If you enjoyed diving into the cosmos with us, don't forget to hit that like button. Your support fuels our passion for exploring the unknown. And if you're as curious as we are, make sure to subscribe and join our community of space enthusiasts. Let's keep wondering, keep asking, and keep reaching for the stars together. Thanks for watching, and until next time, keep looking up.